I'm Maximilian Grau, and machine vision is rising. Every time, more and more machine vision is used in automation systems. But if you ask your colleagues, then they always say, machine vision often finishes as last in an automation project. And there are many reasons. In a machine vision project, first, you have to rent the components, and you have to make looking which components do you need, which camera system, which illumination system. Then you make a feasibility study. It means you need first the physical part to look which components you need. This takes time. And after them, you can start to program your imaging processing software. The next problem is, if you want to test your inspection system, you need the real assembly line. So you have to wait until the mechanical and electrical engineering are ready with your work, with this work. Then you can finish it. So this is the reason why machine vision always comes at last in an automation project. So we are the startup Medabsy from Dingolfing, and we want to change the game. We want to make it able that everyone can solve the machine vision challenge before you have the hardware. This is one of the craziest and most difficult ideas you can have in machine vision, but it's one of the most promising thing what you can have in machine vision. And we are doing this with what's called digital twins. So here you see on the left side our software platform, our web browser platform, and it works like this. In our platform, you upload a 3D model of your target, and then you choose a material. After then, with our database, you can choose the right components. We have all cameras, all lenses, and all illumination you have on the market. You set up in the system, in the scene, and then you get in minutes a synthetic, realistic image, like this one. And this whole process takes only some minutes. Here, with this case, you save a lot of time of the whole project. Why? Because a lot of steps you can do it digitalized and not in real. And of course, you can put some task in for. So here, another examples. The benefits of digital twins are you can change everything. You can change lights, position, materials, or the last one is the most interesting stuff. You can add defects. So if you have synthetic images with defects, you can look, okay, how to program your imaging processing software. So it means you can solve it before the errors happens. And this saves a lot of time and money. Here's one customer of us with the proof of concept. Thank you to BNR that we can show this project. We did a digital twin of the system, and with their components, we put the stuff in the right position, and then we did the synthetic images. Now you can compare it side by side with the real image. Looks really realistic. So generally, what can you do with digital twin? You can choose the best strategy, how to solve the machine vision challenge. You can save time. And it's also a really good tool for sales. It's not for engineers, also for sales to convince the customers, okay, which components they need. The second big use case is we can also generate not only one image, you can generate unlimited image, 1,000 or 10,000 images, which are also automatically labeled, pre-labeled. This is not manually labeled. This is with our platform label. And with this training data set, you can train your AI for it. And we also generate metadata from each image, which can you also provide to your AI. Here also some examples what we can change. We can change the color if you have many parts, or we're doing binary images. And this, of course, saves also time. And the one big benefit is if you are missing data, if you have a lack of data, you can fill it with synthetic images instead of real data. So you have a bigger balance of the data. So what are we offering? We are offering three stuff. As a first, as a service, if someone needs a training data set or want to see a digital twin, we can offer, we can do it for a specific project, but our main business are license. We are offering 1 year license where the customers can get access to our platform to generate their own digital twins and synthetic images. And then, with the feedback of the market, we built another business model, the white label solution. Because a lot of components manufacturers want to add this platform in their website to accelerate their sales. So you have a white label solution with only your components. So there are many benefits, many stuff you can do with digital twins and synthetic images. Our goal is, of course, solve your machine vision challenge before the hardware. But 3 things you should remember. First, show 1 million inspection system with only 1 laptop. Second, generate synthetic pre-labeled data just in minutes instead of hours or weeks. And the third one, accelerate your sales with simulation and convince the customer. We have our booth here. You can see our platform. Also, our simulation expert is here. Have a talk. And yeah, for the next machine vision project, if someone asks you, what is the status of machine vision? You can say, we have already done. Thank you.
Wow, perfect timing. One quick question, but a quick question. Mark, our chairman.
Hi there. That's great. The question I've got is, how do you create the digital twin of the camera or the light profile? Because that has to have a specification that is unique to that product. And how do you create a digital and how long does it take to create the digital twin? Because you need, in theory, every product that's out there that's here in this show to have a digital twin, and that must be a very time-consuming task.
And an accompanying question from pretty close to that. How close is virtuality and reality?
What is the...
How close is virtual and physical world? I mean, you have a digital twin.
Yeah.
And if you did it physically, you may have still a little gap there.
Yeah.
So how close is that to reality?
Okay, now it's from my acoustic. Okay, the first question I want to answer. So at the moment for the customer project, what we have, it's enough with the technical sheets. What is the most components manufacturing is offering. We're taking this data, for example, the pixel size and pixel width and everything, and then we put on our platform. At the moment, we're doing manually, but in the future, we have to look how to automate it because there's a lot of components in the market. But at the moment, this is enough. And the second question, this is a really tough question because there's no algorithm or mathematical form to measure the quality of what is reality and what is synthetic images. This is the reason why we show always what is a real image, what is synthetic, so we have an opinion. But this is something that is at the moment there's also no research or something. Also we can't get at the moment a number. But for example, the slide with the range I showed to to a lot of people, and I asked them, hey, what is the real image? And 60% said the wrong image is the real image. So they're really close.